Anyways, so yes, power series. Well, power series for sure is probably going to be on there. It's kind of an easy one to ask online. So let's start with something like this. 5 to the n. So with power series, you always use ratio test. So what's the ratio test? The ratio test is you compute this ratio and then whether this is less than 1, greater than 1, or equal to 1, they do separate things. So if it's less than 1, it's convergent. And this is divergent. And then this is no conclusion. Okay, and so for this one, minus 2 n plus 1 over n plus 1, 5 n plus 1 times 5 to the n over n and x minus 2 to the n. And so this is going to be x minus 2 over 5 times n over n plus 1, which goes to x minus, I'm going off screen, no, x minus 2 over 5, because this part goes to 1. And then you have to make sure that's less than 1. So x minus 2 is less than 5. So that's your radius of convergence. This is your center. And now you still need to figure out the interval. So 2 plus 5 is 7. 2 minus 5 is minus 3. And so this is your interval, except that you have the endpoints to worry about. So everything in between here converges, but then negative 3 and 7 are a different story. So x equals negative 3. If you plug that into here, you get negative 5 to the n over 5 to the n and n. And then summation. And so that becomes negative 1 to the n over n. And now this is an alternating series because you have this thing here. Whenever you have that, it's an alternating series. And if it's decreasing and it decreases to 0, so 1 over n, right, is always constantly decreasing to 0, that means it's convergent. And so it's convergent here. And over here, it's, if you plug in x equals 7, then you get this. So you get 1 over n, so x equals 7. Then the sum becomes 1 over n. But that's divergent because it's a harmonic series. And so it converges over here and diverges over here. So negative 3x and 7. And so it converges, or this is the interval of convergence. Can we use root test as well? Yes, you should be able to. for power series. But you have to be a little bit careful because computing the limit gets a little bit tricky. So I would recommend ratio test, but you can use the root test. It's just like what happens if you do the nth root, then all this is fine, but then you end up with an n to the 1 over n, and then computing this limit is not that fun. So, well, it's actually just take log, so it's not that bad, but I think ratio test is a lot easier. Anyways, 4n plus 8 to the 2n divided by that thing. Okay. Could you talk about the final sample later? Which one? Because we'll talk about the first sample final one tomorrow. 4n plus 8 to the 2n over negative 5n minus 1 to the n. And you're asking if this is a convergent or divergent series. Practice problems you gave. Oh, yes, I guess so. So for this one, I would probably use the root test because then everything becomes nice and easy. Or, well, everything has an nth root. So when you take the everything has an nth power. So when you take the nth root, then those go away. So the limit is pretty easy. What? Power series, right? This is not a power series. Or, yeah, it's power series is something with an x here. So is this not the question that you're asking? Well, anyways, let's just, what? Okay. Oh man, teaching online next quarter is going to be like not so good. But then I think everyone's going to use Zoom. And so for that, you can broadcast yourself to me and then you can be a bit more clear. Because typing all this math on a keyboard is kind of hard on YouTube. But, well, okay, so let me just do this problem, this fictional problem. So an is all this. So 1 over nth root is 4n plus 8, and then 5n plus 1, and then all that to the square root. And actually, there's going to be a square on here. So, oops, it's going to be 4n plus 8 square. So the n factor is bigger here. So this goes to infinity, which is bigger than 1. So it diverges by the root test. You could also compute the limit of this thing as it goes to infinity, and that's going to be bigger than 0. So by the divergence test, it diverges. Can you use ratio to solve this? An equals, okay, let's try that. Square root of n plus 5 times n plus 3 factorial divided by e to the n minus 5. So this one, if it's a sum, diverges because n factorial is the biggest of them all. So the limit of this thing is just infinity. So it diverges. But yeah, I think if you use the root test, are you sure the n plus 3 factorial isn't down here? Okay, so yeah, let's assume it's a series question. So if it's this, then you can pretty quickly show that this thing is infinity, the limit, but you could also use the ratio test. So if you use the ratio test, this is going to be n plus 6 and n plus 4 factorial divided by e to the n minus 5, no, minus 4 times e to the n minus 5 and n plus 5 n plus 3 factorial. And so this is going to be square root of n plus 6 over n plus 5. You always want to kind of rearrange the like terms. So this is going to be what? E to the n minus 5, e to the n minus 4. So there's 1 over e left over on the bottom. And then this is going to be n plus 4 on the top. And no factorial times 1. And so this goes to infinity. Okay. You could always do this thing pretty quickly, like n plus 4 factorial over n plus 3 factorial. This is n plus 4 times n plus 3 plus n plus 2 all the way down to 2 times 1 divided by n plus 3 factorial is n plus 3 times n plus 2 times all the way down to 2 times 1. So everything cancels except n plus 4. So that's how you do some shortcuts with factorials. Are we going to talk about the answers for final sample questions? So I guess the ones that I wrote. So let me pull it up because I don't remember what I wrote. Oh, I even called it final sample questions. Well, okay. So most of the integral ones, I would suggest using symbolab.com. And that thing tells you how to do it most of the times. But let's see. So let's start off with number 1. So with this one, it's kind of hard to do all at once. So whenever you can, you should split it up into 2 pieces. So this is t e to the t dt plus integral ln of t dt over t. Then these are rather straightforward integrals. This one is integration by parts. This one is u substitution. This one, you have u equals t, dv is e to the t, dt, and du equals dt, and v equals e to the t. And this over here, you would let u equal to natural log of t, then du is 1 over t dt. And so when you do that, the answer will be t e to the t minus e to the t plus natural log, no, 1/2 natural log of t squared plus c. So the trick was to split it up, the sum, and don't try to do it all at once. The next one, sine square plus cosine square, you do something like this. So you have the cosine angle reduction identity. And you have the sine angle reduction identity. Or sorry, the degree reduction. Okay, but then for this particular one, there's something kind of cool that you can do, which is that 2 sine theta cosine theta is equal to sine 2 theta. Or in other words, sine theta cosine theta is equal to 1/2 sine 2 theta. And so then if you square everything, square, square, this is square, and this becomes 4. So you can just replace that to that. So this becomes 1/4 sine square 2 theta theta. And then you can use the degree or power reduction identity. 2 thetas here, and then this becomes double. I mean, right? Theta is not important. We can replace it with x. So if x is 2 theta, then this is going to be 1 minus cosine 4 theta all over 2 d theta. And so this is 1/4, actually 1/8, because you factor out a 2, and then theta minus 1 over 4 sine 4 theta plus z. Okay, so these trig identities come in handy. The more you know, the better. The next one is kind of hard. I shouldn't say hard. Is it same if I write x? Oh, my bad. I guess I had this as x. So that changes everything. So everything becomes x. So this is x and x. Okay, so the next one is this one. So a little story about this one. This one was supposed to be on the midterm. But then I realized that it was too hard. Well, no, it wasn't too hard. It was too long, because the midterm had this, and then it had a 2x, and then it would have been cool if it had just like a 1x, because each of those integrals you do like totally different. But I decided against it. So this one, you have to do this. Rewrite it as this. And so you do t equals e to the x dt is e to the x dx, so that integral 1 plus t squared dt is the integral that this becomes. Try to be nice. No. Anyways, so then this becomes a trig substitution. because it's some number plus something squared. And then this is going to be tangent. So t equals tangent theta dt equals secant square theta d theta. And so this becomes 1 plus tangent squared theta times secant squared theta d theta. So it becomes secant cubed theta d theta. So then this is everyone's favorite. You have to use integration by parts. So this you have to use u equals secant theta dv equals secant squared theta d theta. And then du is secant theta tangent theta d theta. V is tangent theta. And so we are running out of room. So let me just copy the problem. And the relevant substitutions. So this was t equals e to the x. And that's all that really matters. And so this becomes uv is secant theta tangent theta minus integral of secant theta tangent square theta d theta is equal to secant cubed theta d theta. But then tangent square is secant square minus 1. So we plug that into here. And so we have secant theta tangent theta minus secant theta and secant square theta minus 1 d theta. So we're almost done. This is secant theta tangent theta minus secant cubed theta minus becomes a plus secant theta d theta. And then this is nice because you can add secant cubed to both sides. And so this is 2 times secant cubed theta d theta equals secant tangent plus the integral of secant is natural log secant theta plus tangent theta plus c. So divide by a half. And that is the integral of secant cubed. But we're not done yet because we have to substitute this back in for u. But u, oh, no. T. But t is e to the x. So e to the x over 1 is equal to tangent theta. So this is the triangle e to the x and 1, and this is 1 plus e to the x squared, so e to the 2x. And so this becomes 1/2 secant is hypotenuse over adjacent, so this is square root of 1 plus e to the 2x times tangent e to the x plus natural log of 1 plus e to the 2x plus e to the x plus c. Okay. Why can't we u sub e to the x? Oh, this is not going to be on the final. Oh, I should say that. Or I don't think it's going to be on the final. Like this is too long. Like for the online final. Yeah. So something like this is, yeah, wouldn't be on the final. I don't even, yeah, I mean like next quarter is 2B class. is probably also going to be online, and that's not going to be this. Are you missing a t outside the square root? Oh, okay. So let me use a different color. So you're probably thinking, wasn't it like this? So no, because when you do this, e to the x square, 1 plus that, then if you let u equal, or t equal e to the x, then dt is e to the x dx. So this is e to the x dx is dt, and this is t squared. So it's not this. And then why can't you do e to the x first? So yes, let's see what happens if you do that. It might work, but I haven't tried. So, whoops, e to the x, 1 plus e to the 2x dx. If we let u equal to e to the 2x, then du is 2 e to the 2x dx. And so you get kind of stuck because this is e to the x. You can't, there's no such thing as square root of u. I suppose you could potentially do this. So root u is e to the x. And you can multiply top and bottom by e to the x. So bear with me. This is going to be e to the 2x over e to the x and 1 plus e to the 2x dx. So this will become 1/2 square root 1 plus u, and then e to the 2x dx is du with a 1/2, divided by e to the x, which is root u. So now you have to integrate this guy, 1/2 square root 1 plus u over u du, which is not easy. Then I would probably do u equals z squared, du equals 2z dz. And this is nice because 1/2 du, oh no, other way around. Yeah, so this is nice because then this becomes 1/2 integral of 1 over 1 plus z squared. And then you have still a root u, but this z is equal to root u. So this becomes z. And then du is 2z dz. So these cancel and the z's cancel. So you end up with square root of 1 plus z squared dz, which is what we started off with anyways. So you can make this substitution. You end up with this integral. And then for that, I end up with this integral. So so you probably just want to use the more simpler substitution. But yeah, I don't know. I mean, integration, this is why it's kind of fun, is you can mess up. Well, there's no such thing as messing up as long as like everything is equal and you're following the rules, then you can eventually get to this form. You just have to have the willpower to do it. Anyways, so let's skip the next one because that one, it's not conceptually that much harder. It's actually the same thing as this, but it's a tad bit longer. And the next one is more fun anyways. Is this right? This is not right. 3 plus natural log 4x dx. I can't. I work on Sundays all day. I work too much. And that work is not canceled because of coronavirus. So, yeah. I can't tell you what I do on Sundays, but it is a job. It's a secret job. No, it really is a job. I work on Sundays. Anyways, so for this one, the messiest part is this part. So you kind of just set that as U and hope that something really nice happens. A lot of times, if you set the messiest parts as U, you should just try it. You know, it's gonna, and maybe it might work. And always having, if you have a plus a constant, then I shouldn't say always, but it's not a bad idea to include it, because when you take the derivative, it goes away. So this is 1 over 4x times the derivative of the inside, which is 4, and then dx. So that's just 1 over x dx. And so now this is very nice, because this is 2, and then 1 over u, and then dx over x is du. So this is not 2 times natural log of u plus c. So 2 times natural log of 3 plus natural log 4x plus c. So any questions with this? Okay, the next one is just, so this is a type of question that you might see on an online final, because this one is easy to ask and easy to answer. So the derivative of 0 to x squared of sine root t dt. So this one is a fundamental theorem of calculus, and so this is equal to sine, if you plug this in, and that's it. Question mark? It is not. You have to, if it's not just x, you have to multiply by the derivative of the inside by chain rule. So it's this times 2x. So if you clean this up, this is 2x sine x. And then no plus c, because you're taking the derivative. Number 8 is also probably a good one to ask on the sample final, because again, it's easy to ask and easy to answer. So number 8 is like -1 to 2 of 1 over x minus 1 dx. The answer is not natural log of x minus 1 divided from 2 to -1, because if you plug in x equals 1, which is certainly in the interval from -1 to 2, it's undefined. Right? If you graph this, it's 1 has a vertical asymptote, and it's like this. And so the -1. Oh, -1, it's negative, so it should be like that. Anywho. I'm actually sorry. It's going to be like this and like that. Yeah, it's going to be asymptotic to 0, because when x goes to infinity, it goes to 0. Anyways, so the area between here and here is infinite, so it's divergent. And remember, to show that, you just split it up into -1 and 1. 1 over x minus 1 plus 1 to 2, 1 over x minus 1. And then this part and this part, they're discontinuous terms, so they diverge there. Find the volume of the solid. So that one's an easy one. You just square the whole thing, and then don't forget the pi. So let's skip that one. The last integral one is also kind of interesting because you have to do partial fractions. So this one, 1 over x squared minus 1. Actually, you know what? Let me do something else. This one from 2 to infinity. This one you can use trig sub, probably sine. But actually, if you do that, changing the bounds for 2 and infinity is going to be a little bit tricky. So let's actually not do that. So never mind. Let's do it the old school way. So this is x minus 1 and x plus 1. So partial fractions. One over x minus 1, x plus 1 is equal to a over x minus 1 plus b over x plus 1. And so 1 equals a times x plus 1 plus b times x minus 1. So if you plug in x equals negative 1, you get 1 equals negative 2b. If you plug in x equals 1, you get 1 equals 2a. And so a is a half, b is negative a half. And then you just integrate. So this is going to be 1/2 natural log x minus 1 minus natural log x plus 1. And so using the properties of log, you can combine this into one thing from infinity to 2. Natural log, well, this, as this goes to infinity, this term goes to 1. So this will be 1/2 natural log of 1 minus natural log. If you plug in 2, you get to 1 over 3, 1/3. And so this thing converges. And that's the answer. So for the series, I'll just maybe, no, I'll do it. I mean, I'll just tell you what test to use, and if it's a tricky application of it, then I will actually go through it, but if not, like the first test. This one is divergent. You just ignore all the terms. It's kind of like 1 over root n, and you can't forget the p series. When p is greater than 1, it's convergent, and when p is less than or equal to 1, it's divergent. This is like p equals a half, and so it's going to diverge. You can use direct comparison, or you can use limit comparison. The next one is a pretty easy application of the root test. So n squared, 3n squared plus 1 to the n. So take the nth root. Can't forget the absolute value, although in this case it doesn't really matter. Then the limit, you just compare the coefficients because it's the same power. So it's 1/3, less than 1, it's convergent. The next one is you have to use the ratio test. It's basically a power series, but you're plugging in pi for x. And actually, this is just cosine without the 1. of pi. So that thing is 0. You could even evaluate it. But anyways, use the ratio test. So this is going to be pi 2. And the ratio test, you take the opposite value. So this doesn't really matter. So this is 2n plus 1 over 2n plus 1 factorial times 2n factorial over pi to the 2n. So if you simplify this, you get pi squared over 2n plus 2 times 2n plus 1, because this is 2n plus 2 factorial. So the surviving terms are these guys, and then this goes to 0. So it's less than 1. Because the ratio test, you have to make sure it's less than 1, so it's convergent. Could you talk about the 7th problem? Well, that's the easy one. So, well, we'll do it next. So the next one, this one's a little tricky. This is alternating series. Whenever you see this, think alternating series. You know that this thing pretty clearly goes to 0 because the power here is 1. The power up here is a half. So the power in the denominator is 0, or no, greater, so it goes to 0. And then to show that it's decreasing, you have to take the derivative of this one. So I don't really want to do that, but this is less than 0 for x greater than, I think, 5 over 2. This looks vaguely familiar. I think we did this in class. Or x equal to some finite constant. So therefore, by alternating series, it converges. And then finally, the last one is the trickiest of them all. 2 to the 1 over n minus 1. So this one, as n goes to infinity, this goes to 0. 2 to the 0 is 1. 1 minus 1 is 0. So divergence test tells you nothing. So you have to do the limit comparison test. So limit comparison was that if you have your if you have a series that you're comparing with, this has a finite limit which is greater than 0, and it's finite. Then the series an and bn do the same thing. So since you have a 1 over n up here, it might not be a bad idea to use that as your comparison. So do 2 to the 1 over n minus 1 over 1 over n. So to take the limit, you use L'Hopital's rule, because if you plug in infinity, you get 0, and 0, 0 over 0 is an indeterminate form. So now the derivative of this is going to be 2 to the 1 over n times natural log of 2 times the derivative of the 1 over n, so 1 over n prime, over the derivative of 1 over n prime. These cancel, so you have this thing. This thing, as n goes to infinity, goes to 1. So this goes to natural log of 2. Natural log of 2 is bigger than 0. So it converges. No, sorry, it doesn't converge. So the series, this series and this series do the same thing, but this is the harmonic series, and it diverges. Or the p series with p equals to 1. So it diverges. Yeah. Okay, so I guess we'll do the rotation. Find the volume of the solid obtained by rotating a graph about the x-axis. So this, So you have this graph, 3, -3. This is y equals 9 minus x squared. So you want to rotate it about the x-axis. So it's just, this is the disk method. So you only have an outer radius. So you square this. So it's going to be 9 minus x squared dx times pi from negative 3 to 3. This is an even integral. So this is 2 pi 0 to 3, 9 minus x squared dx. So you integrate it and you get 2 pi times 9x minus a third x cubed. Plug in 0 and 3. So just plug in 3. So this is 2 pi times 27 minus 3 to the 3 over 3 is 3 squared, so 9, which is 18. 2 pi times 18, so 36 pi. Sounds about right to me. In fact, this, if you think about it, is a circle, the whole thing, and it's rotated like this. So it's actually the volume of a sphere of radius 3. Volume of a sphere is 4 pi r cubed over 3. If you plug in 3, you get 4 pi 3 squared. So 4 times 9 is 36 pi, which is the same thing as over there. So any questions of this? Okay. So the next two ones are geometric series. The last one is the telescoping series. So this is 2 to the n plus 3 to the n over 5 to the n. So if you split this up, you get 2 to the n over 5 to the n plus 3 to the n over 5 to the n. So you can split this up into the sum, 2 over 5n plus 3 over 5n. Let me just make sure it starts at 0. It doesn't. It starts at 1. So in order to make it start at 0, you have to factor out, right? 2 over 5. And this is 2 over 5 to the n minus 1. N equals 1. So when n equals 1, this is 0. So actually, we can just re-index this, make it k. And this is k equals 0. Same exact logic holds. You factor out this thing. You have k equals 0, infinity of 3 over 5 to the k. And now these are geometric series. If it starts at 0, this is 1 over 1 minus r, as long as r is less than 1. And 2/5, 3/5, they're less than 1. So this whole thing is 2 to the 5 times 1 over 1 minus 2 to the 5 plus 3 over 5 times 1 over 1 minus 2 over 5. Okay. You can simplify that if you want to. And the next one is somewhat similar. So I'll just tell you how to start it off. So this is 3 to the n plus 1, and then 4 to the n. N equals 2. So you can factor out 3 squared over 4. No, actually, you could even do more. You can factor out 3 cubed and 4 squared, so that this becomes 3 to the n minus 2 and 4 to the n minus 2. So this becomes 3 cubed over 4 squared, n starts at 2, n starts at 2, of 3 over 4, n minus 2. And then you can kind of see what's going to happen is that n equals 2. This is 0, so you can re-index and make it a geometric series that starts at 0. Okay. So the last one is a bit of a pain, and I doubt something like this would be on the exam. So I'll skip it. But a good one to practice is something like this one. That's an easier version of that question. It's a telescoping series. So you first do the partial fractions, and then your middle terms cancel. So you end up with something like 1 over n minus 1 over n plus 1 or something like that. And so then you just write out the first couple of terms. 1 minus 2 plus 1 half minus 1 third plus 1 third minus 1 fourth, etc. So you see that these middle terms cancel out. And so whatever you have left over is your sum. I don't know if this is correct. Actually, you could do it really quick. So n plus 1 times n and n. My God, it's correct. Okay, so I got pretty lucky there. Taylor series is just the formula. And especially for sines and cosines, you can find a pattern. So the Taylor series of a function centered at a is f of a plus f prime of ax minus a plus f double prime of a over 2 times x minus a squared plus f triple prime a 3 factorial x minus 3, no, x minus a squared, etc. So the summation form is n from 0 to infinity f of the nth derivative at a n factorial x minus a to the n. This is the nth derivative. So just plug that in. The series for sines and cosines are very well known. So just look it up. And we already did a bunch of the radius of convergence ones. You could even sort of guess, like, so definitely you should carry out the steps, but like with this one, the only, you think about the order of growth of functions. And so a polynomial, n to some number, doesn't grow as fast as x to the n, these, or 4 to the n. These things grow fast because the n is in the exponent. So what really matters is going to be this term, which should be less than 1. And then from here, you would know that if you plug in at the endpoints, so 4 and -4, you're going to get -1 to the n and 1 to the n. So it's going to be either the series 1 over n to the fourth, or -1 to the n divided by n to the fourth. But then it's n to the fourth, so both endpoints will converge. So you're going to end up using the alternating series test always for these ones. So you can more or less guess what's going to happen. But again, just use the ratio test. Okay, so any more questions? All right, it's getting kind of late and I have to get up early because I teach at 8 a.m. So I'll wait for like 5 seconds. If there's no questions, then I will end the stream. Oh, do you think making the percentages of higher than that is a good idea? That's actually a possibility that's being discussed with the math department. So that might happen. But I mean, the final, I don't know if it's going to be that hard. So you might want your final grade, the final exam grade to be higher. I'm not saying it's going to be easy. I don't know. Yeah, I'll curve the entire grade, of course. So yeah, I mean, I guess if I'm to curve the entire course grade, it doesn't really matter what the weighting is, because everyone's going to be graded the same. I mean, curving means that the top 25% of you get A's, the next 25 to 30% of you get B's, and then next batch gets C's, etc. So I don't know. So the rankings, it doesn't really matter too much how you shift the weight. Just give us A's for being in a pandemic. I'd like to do that, but I could get fired. So that's a little tricky. Yeah, I don't know. We'll see. Oh, no, we won't see. That's a no. But we'll see how the quarter goes. All right. So going once, going twice. The stream is now over.